Muscle action and coordination. Well, take a look at this guy. You see, our muscles don't all flex and extend at the same moment. We have synergists, we have prime movers, we have stabilizers. A lot of things are going on in every movement we take. And this is a good example there. The chart here is just showing the degree of workload, and you can see how it changes. And there's a reason for all this, and we're going to get into that. First, let's look at this idea of muscle attachments. It's a pretty simple concept. Origin is the attachment at a stationary or relatively stationary part of the body. The insertion is a more distal, movable part. So we have here, we're looking at the this is the triceps, the triceps, and the belly is the middle. Now, sometimes there's a reverse muscle action called RMA, and in those cases, the insertion becomes the attachment. Now, I don't want to go into too much detail here, and that is one of the reasons that I generally refer to muscle attachments. Origins and insertions, that's the traditional way of describing muscles, and it's appropriate most of the time. I like to just refer to attachments for the most part, and that tells us a lot. And then we don't have to worry about RMA at all. Lever systems, well, three basic things we're looking at. Fulcrum is this triangular structure, and it's kind of the fixed point. The effort, we call that E. That's what generates movement through muscle contraction. And the load, L, is the resistance. Sometimes it's called resistance instead of load. You'll see it written both ways. Good example here, bicep brachii. It's going to flex and raise the forearm, so that's effort, E for effort. And the load's going to be the hand, the weight of the hand, plus whatever the hand's carrying. Now we have a mechanical advantage when the site of effort and load are close to the fulcrum. Okay, now think about this for a minute, because I know these are new words. This is the fulcrum or axis. If the load or resistance is close to the fulcrum and the effort, then we have advantage. Disadvantage is if it's far away. And just think about that. Okay, if this is you and the force is way far away, then it's going to require more energy to move it. Right? I think we know that. A long seesaw versus a short seesaw. We'll look at some good examples here. We have a first class mechanical advantage or disadvantage depending on the location of the load and effort. All right, we don't have a lot of these because in a way it's not as effective as some types of levers. Let's look at the neck. Okay, so the front of the skull is the load. So like if you nod your head forwards, that's like a load. The fulcrum is the joint at the base of the skull, the axis connection to the occipital condyle here. And so when we move our neck muscles, the scalenes and trapezius there, then the load's going to move. Second class is where we have a load between the fulcrum and the effort. And think of a wheelbarrow. Here's the fulcrum. Here's the effort on the end. And there's a load. Good example here is the calf muscles, the gastrocnemius, the soleus. When they contract, then we get this plantar flexion. And so the fulcrum is real close to the load here. In third class, the effort is between the fulcrum and the load. And if you look down to lower middle, you'll see what we have is like a forceps or a tweezer kind of idea where the fulcrum's on one end, load is on the opposite, and the effort here. So this is going to have greater speed than the second class, but the second class is more powerful. Okay. Fascicles are how muscles are arranged in microscopic fibers, and then they clump together and form these different shapes, and the shape influences how they function. Let's look at circular. We'll start with the Orbicularis Oris. So this is the kissing muscle around the lips, and it attaches on itself. So these tend to be sphincter-like, and they're going to enclose openings or orifices. So the mouth just being one of these examples. Triangular is where we, pectoralis major. So this large muscle, the origin near the sternum here, attachment over here on the humerus. The shape pretty much describes it, that kind of fascicle. Parallel sternohyoid, which is not easy to see in this picture up near the throat, but certainly the sartorius is. So these are going to be long, narrow fascicles. Unipinnate, down the lower left, we think of the extensor digitorum longus in the anterior part here, near the tibialis. On the other side, we have multipinnate. So we think of the deltoid, which has different regions based on these fascicles. Fusiform, good examples, the bicep brachii. So we have this wide belly, and then it tapers down to both ends where the tendons are. Bicep, see two heads, so you see these two sets of tendons. And bipinnate, which is, okay, the tendon here, and then there's fascicles on both sides of the tendon. And we think of the rectus femoris, rectus meaning straight, right down the femur, with two bipinnate. All right. Coordination. Muscles are arranged either as antagonists or agonists. And so let's look at the agonist or prime mover. More often you hear the prime mover. That's the one that contracts to cause body action. And then the opposing lengthens and stabilizes. But it generally doesn't resist. It might provide a little stability, but it's not going to fight against the prime mover. They're often on opposite sides. So let's look at the example. Sometimes examples tell the story really well. Here's the biceps brachii of the arm. When it contracts, we're going to get a flexion of the forearm. That means the angle decreases. And while that's happening, the antagonist, which is the tricep brachii, is going to relax it a little bit, but it's still going to be there. Okay, it still has tone, and it'll stabilize a little bit. But now when the tricep becomes the prime mover, then the bicep, okay, so when it does that, here we have it on the far right, it becomes a prime mover, and the extension, now it's the biceps' turn to stabilize and to relax. We also have synergists, and synergists, it's sort of like, okay, the prime mover is the hero, the leader, but the synergists are they're going to assist the prime mover and kind of stabilize any unnecessary movements. So synergists are crucial. This often happens when a muscle crosses over a joint. And let's just take a look at that again. Sometimes we look at examples, then it all becomes clear. We look at the Flexor Digitorum Profundus, which is deep. Okay, so there are muscles on top of here. You have the extensor digitorum, palmaris longus, and so forth. So deep to these is the Flexor Digitorum Profundus, and you'll see that it crosses over the intercarpal region between the wrist bones, and it crosses over the radiocarpal, which is kind of the joint between the radius, the forearm bone, and the wrist bones. So my point is, I mean, there's a lot of words that I guess we don't really need to know to understand this. My point is, okay, here's the joint. Here is this long muscle, and then the tendons. And what's really cool is you can flex your fingers, that is, curl your fingers inwards without flexing your whole wrist. And that's due partly because it's the synergist going over that joint. There's multiple joints, right, in the fingers as well as the wrist. I want to continue with the synergist just because sometimes it's a little bit hard to understand. They may help prime movers just by adding force to the same action, or make small movements possible. Examples of Brachioradialis. Okay, so here we have the Brachioradialis, the top muscle on the top of the forearm, superior side, I should say. And there is the Flexor carpi radialis. Now they are going to help with the flexion of the bicep brachii, which is the large muscle that we're often familiar with. So these guys don't work alone. They get help from, and also the brachialis here, which I didn't mention. So they get help from lots of synergists. Same with the gastrocnemius. This is the visible muscle that we see, but underneath is the soleus, it's shaped like a fish sole, and it also helps to plantar flex, helps you to go up on your toes. Synergists may take on some of the agonists or prime movers action, such as when the gluteus maximus, okay, the huge buttocks muscle, is, if we have a severe injury, often in the tendon here, then the gluteus medius, which is up here, this is where we often give injections for certain kinds of vaccines. Gluteus medius, which is under or deep to the gluteus maximus, and also the semitendinosus down here, lower right, and the biceps femoris. These are on the back of the leg. These are often called hamstrings. All of these muscles are going to pick up the workload of extension and lateral rotation that the gluteus maximus did when it was fully functional. Fixators, okay. These are sometimes called stabilizers, and that's why I sometimes remember them. They're going to hold one bone in place so that the agonist or prime mover has a stable platform. A good example here is the trapezius. Okay, it's going to hold the head, neck, and the scapula here, so that this is all a rigid structure. Now think about this. What if some of your powerful neck muscles, like the sternocleido, start to pull back on the head? We don't want our neck flopping around like a fish or something. So fortunately, the trapezius and other muscles are going to keep this nice and rigid. Also, the scalenes in the front of the neck, they're not really highlighted, but you have muscles called scalenes in the front of the neck, and they're going to stabilize that interior region so that when the big, powerful sternocleidomastoid, the large muscle of the neck, lateral side, when it pulls, our neck's not going to wobble. We can't. There's vertebra in here, a spinal cord. We can't afford to crumple this region at all. Fixators of. Just continuing with the story here. So they tend to stabilize the proximal end so that we can have movement at the distal or at the tips. A good example is the scapula. Again, I like the scapula because scapula is so incredibly movable, and there's many muscles attaching to it. Let's say when the deltoid contracts, it's going to pull and abduct, so it's going to lift the humerus away from the body. And when it does so, there's going to be some other muscles engaged, such as the trapezius, what we just talked about here. Trapezius is going to help maintain the position of that scapula. But also look at the lower part. You're going to have pectoralis minor, which is under the pectoralis major, and to the far side, well, it's really on both sides, serratus anterior, jagged muscles, are all going to work to stabilize the scapula. There's the deltoid. Now watch, it's going to abduct the humerus, and when it does so, see how that scapula is not moving? You think it should, because all that force is being generated here, but there are many muscles that keep it all in place. All right, thank you for listening.